Okay, so again, we're back with the Module 7 lab activity, which is all about the Hertzsprung-Russell diagram. And again, here's the main page that you get to by clicking on the link to the lab simulation. It brings you to this main page. We've already talked about the background information. Again, spend a lot of time with that. It'll help you answer several of the lab quiz questions. But now we're going to focus on the actual HR Diagram Explorer. When you click on that, you wind up with this simulation. And in fact, I'm going to refresh mine to get it back to its original look. When you bring it up, notice that you have the HR diagram, which we're going to actually learn about through the process of using the simulator. But you're also going to notice that you've got a couple of stars here. You've got a star that you're going to play around with, and then you're going to always have the sun over here as a way of comparison. And so really this is a pretty simple simulation. What you can do is just click, right now the cursor, this little red X, is in your on the graph. If we read like the Y coordinate, well, the Y coordinate is 10 to the 0 luminosity. Now, one thing that may be unusual for a lot of you is looking at this axis here. This is what's called a logarithmic axis, and you'll have to understand your scientific notation here. 10 to the 0. Well, anything to the 0 is 1. So really 10 to the 0 is another way of saying 1. So this position on the graph is a star that has a luminosity of 1 with respect to the sun's luminosity. Well, that makes sense. This star has a luminosity of 1 solar luminosity. And likewise, if we go down on the x-axis, notice what the temperature is. The temperature is 5800 Kelvin. In fact, you see the current, wherever the cursor is, it shows you the temperature of that star and the luminosity of the star. Essentially, you're seeing the y-axis value and the x-axis value. Well, what star do you know that has a luminosity of 1 solar luminosity and has a temperature of 5800 Kelvin, otherwise known as 1 sun luminosity? It is our sun. So we're seeing right now our fictional star here is essentially our sun. It has a luminosity of 1, has a temperature of 5800 Kelvin. Now notice that as you go from right to left on the x-axis, that's relatively unusual in the sense that our values go up. We're used to looking at graphs where as you go from left to right on the x-axis, the numbers get bigger. Here, the numbers get bigger going from right to left. And notice they don't get bigger in a uniform fashion. We have an increase of we go from 5,000 to 10,000 in about the same space that we go from 10,000 to 20,000. And in the same space we go from 20,000 to 40,000. So notice that on the x-axis, the numbers are somewhat compressed. So this is not a linear kind of scale. It's more of a logarithmic scale. And likewise, in the luminosity. Remember, we already talked about 10 to the 0 being 1. 10 to the negative 1 is 0.1, 0.01, 0.001, 0.0001. That's what 10 to the negative 4th is. And then going up, 10 to the 1st is 10. This is 100. This is 1,000. This is 10,000, 100,000, a million. Okay. So notice that the y-axis, the scaling is a little unusual. You may not have seen a logarithmic scale like this, but it allows us to essentially compress the data onto the y-axis. So all you have to do then is just click around. If I click to the left here, I wind up with, notice my comparison star now has a temperature which is much greater than our sun. And notice that the star, if you can look carefully, mine's blue, kind of bluish. So the temperature is much greater than our sun. However, the luminosity is only 5/100th that of our sun. Okay, and therefore the size of the star, it's much hotter, but it's less luminous. That tells us it must be much, much smaller. And so notice that it is tiny compared to our sun. That's why the sun is always going to be there on the right to provide you with a way of comparing. And then if you click way up to the top, notice that the fictional star now is huge. It's slightly warmer than our sun, but it's much, much more luminous because mainly of its size. And so that's all you do. You just click around and figure out what are the properties of the different stars located in different parts of your HR diagram. Then you can also plot some stars. So notice there are a couple of little radio buttons at the bottom of the simulation that allow you to plot the nearest stars to our sun or to our solar system. It'll plot the brightest stars that are seen from the Earth, and it'll plot both the nearest and the brightest stars, and it'll also plot the overlap. So all this will help you get through the activity, and most importantly, will help you to understand some of the very key relationships that develop when we start plotting stars on the HR diagram. I hope that was helpful, and I hope you find this activity very useful.